Welcome back to the game show Flunk or Fail, the game show with loose rules, no points, and only answers. We ask one question. Will Andrew vote flunk or fail this assignment? And we leave that up to you, our one viewer. You, yes you, our one viewer, decide whether we flunk or fail. Let's get right into it and move into our first question. Here is your first set of questions. First problem, let's start with changing this into sine cosine, and let's just change those ones into cosine squared x over cosine squared x, because I already know those tangents are going to be sine squared x over cosine squared x, just so we have the same denominator there. So cosine squared x over cosine squared x, over cosine squared x over cosine squared x, because that is the same thing as 1. So then plus minus up here, sine squared x over cosine squared x, sine squared x over cosine squared x. Use reciprocal to change this into 1 over sine x, and then odd identity to change this into negative sine x, which would just be over 1. So then we can take this, so that'd be sine x over sine x, both negative, so it's positive, so that's 1, so plus 1, these same denominator, so it'd just be cosine squared x minus sine squared x, which we know is equal to cosine 2x with double angle, so let's just change that right now into cosine 2x, and then over cosine squared x all over, so the same denominator, cosine squared x plus sine squared x, which would just be 1. So 1 over cosine squared x, flip this small division into multiplication, so cosine of 2x over cosine squared x times cosine squared x over 1 plus 1, these out, that's just 1, and then over 1, so cosine 2x plus 1, using double angle we can change this into 2 cosine squared x minus 1, and then move plus 1 down, cancel those out, we are left with 2 cosine squared x. Alright, so for the second half of this, first thing we do, we write a sine cosine, so we'll make that 1 over sine theta minus cosine theta over sine theta, so in fact 1 over sine theta plus cosine theta over sine theta, simplify into 1 minus cosine theta, 1 over 1 minus cosine theta over sine theta, so then I can change that using my half angle identities into 1 over tan half theta, and then minus 1 over cotan half theta. Here rewrite this one as 1 over tan half theta, minus 1 over tan half theta over here. Switch this around, so 1 over 1 times tan half theta over 1, so 1 and 1, 1 and 1, so tan half theta over 1, so that would make this 1 over tan half theta 1. And then I'm gonna multiply this side by tan half theta over tan half theta, so they have the same denominator. So then that becomes 1 minus tan half tan squared half theta over tan half theta. Let's see. And then I can use double angle to change that into 1 over 1/2 tan theta. And then I can change that into 1 over tan theta over 2. And I can put that around into 2 over tan theta, which I can use that, and that will simplify into 2 cotan theta, proving that our original equation equals 2 cotan of theta. Alright, transition from our second to first answer. Wow, that was a great answer, Andrew, for those first set of questions. Each set is 2 questions, 3 sets of questions, and 3 sets of answers. Alright, so we are unsure if that was right or not, because, we're not grading this. You are, so that's on you, bud. Pew, pew. Next, we'll be moving on to your second set of questions. Okay, so for number 3, I know we need to find cosine of 2 theta, and we already have sine of theta equals 4/5. Using double angle, I know we can change cosine of 2 theta into 1 minus 2 sine squared theta, and then we can just substitute sine in there. So 1 minus 2 4/5 squared. So 4/5 squared. 16 25ths times 2, and then 1 minus answer minus that negative sign, 1 minus answer, we get so cosine of 2 theta would equal negative 7/25 for the first half of that problem. First thing we're going to do is transform this into sine and cosine as always. So 5 over sine of theta minus 1 all over sine theta times cosine theta. This is a equal sign. And then plus 3 over sine theta. We want to move all this stuff on the other side, so we 5 over sine theta minus 1 over sine theta cosine theta minus 3 over sine theta equals 0. We want to change this all to the same denominator, so multiply it all by cosine theta. So let's just make this all over sine cosine theta, because they're all going to have the denominator. So 5 cosine theta minus 1 minus 3 cosine theta equals 0. It has to equal 0, so the denominator is going to automatically be 0, so we can take that out. Combine common factors on top, so that would be 2 cosine theta minus 1 equals 0, plus 1 over here, and then divide by 2 over here, so cosine of theta equals 1/2. On our unit circle, there are, the first one we got is pi over 3, and then 5 pi over 3 on our unit circle, and those are the only ones that fit in our range of 0 to 2 pi.
Wow, another beautiful set of questions. And did you notice earlier I shamelessly stole, not shamelessly, but whatever. Family Feud music earlier from the intro. Yes, it's all in there. All right, next questions. Go for it.
Here is your third and final set of questions.
Alright, so for our next problem, find all solutions of 6 sine squared x minus sine x minus 2 equals 0. Let's factor this out. So let's let sine x equal u. So 6u squared minus u minus 2 equals 0. 3 and 2? Yeah, 3 and 2. So we can factor that into 2x plus 1 and 3x minus 2, which gives us solutions. Oh, not x, u. I'm using u. So 2u, 3u. So u will equal negative 1/2, and u will equal 2/3. So let's put sine x back in there. Sine x equals 2/3, and sine x equals negative 1/2. So that will be x on our unit circle, x equals 11 pi over 6, and then plus 2 pi n, and x equals 7 pi over 6 plus 2 pi n. Alright, so for our last problem, find all solutions of 3 tan 3x equals 9. Let's see, how am I going to do this? Let's do it. Okay, so divide by 3. So tan of 3x equals 3. So we can use inverse. So 3x equals tan negative 1 of 3. So let's put that into our calculator. So second tan 3, and we get this number. And then we still have to divide by 3 from the other side. It's 3x divided by 3 equals 0.416. So x equals 0.416. And then for tan, we add plus pi n, but we divided by 3, so it will be plus pi n over 3. And then that is our solution.
Wow, what a wonderful way to end this video with those questions there. That was truly wonderful. Hey, you audience member, if you stick around, you can see the amazing setup I have for recording those math videos, because it's like, I don't know, I think it's pretty professional. Not to my own horn or anything, but I thought it was pretty professional. And I'm gonna end this off signing out because it is getting extremely hot in this suit.